So as with most projectile motion problems, we have to keep track of the x information and the y information independently. And we hope that one of the directions will give us the information we need in order to solve for the other set of equations. Occasionally you may have to use x and y equations together with two unknowns, two equations, and solve them simultaneously. But that's not always the case. So in this situation, we're trying to find the final position. We know the final y position, so we actually know more information in the y direction than we do in the x. So we should look and see what we know in the y direction. We know the starting height. We know the final height, the starting y velocity, the y acceleration, and we don't know the time, but that usually is the variable that connects the x and y directions together. So we can use the third kinematic equation to solve for the time. So all those values are just being read straight off the picture, the heights, speeds, and acceleration. So we can rewrite this. So you can use the quadratic formula to solve for time, or your calculator, and you come up with 2 times. One of the times is negative, one is positive. Looking at our picture, we can see that we want the first time in the future when the sled reaches 0 height. The negative time is actually telling us about the time to go backwards. If you followed a parabolic path like this, it would take 3.7 seconds to reach the ground. Of course, the sled's not going that way. We just care about in the future. So the time that we want is the 6.32 seconds. That's the time we can use in the x equation. Again, we have enough information to find the thing we want. This time it's the final x position. And so let's see what we have for the third equation. In this simple problem, there is no acceleration in the x direction. If we had wind blowing, a rocket attached that was firing, there may have been an acceleration in the x direction, but not in this problem. So we actually have a very simple equation, and the time we already know. And so we end up with the final position for the sled when it hits the ground is x equals 116 meters.